Okay, this video is on the law of cosines, and we're going to start off with this example from the notes. It says two hot air balloons are approaching a landing field. So here's my two hot air balloons. Here's my landing field down here. One of them, it says, is 12 meters from the landing point. So this one right here, let's say, this is the one that's 12 meters away from the landing point. The other one is 17 meters away from the landing point. So this one here is going to be, put this one like this. This one is 17 meters from the landing point. The angle between the balloons, that's this angle here, is 70 degrees. How far apart are the two balloons? In other words, I'd like to know what is this distance here. Well, I've got a triangle here, and I know that the law of sines is often very useful in solving these types of problems. So let me label my sides of my triangle here. Let me call this side A, which is opposite angle A. Let me call this side C, which is opposite angle C, and I'll call this side B. And let me see if I can set up my law of sines here. So law of sines says sine A over A equals sine B over B equals sine C over C. And let me fill in my information here. Sine A, that's going to be sine of 70 over side A, which I don't know. Sine of angle B, I don't have angle B, over the length of side B. I do have side B, which is 17. And then the sine of angle C, let's see, I don't have angle C either. Sine of angle C over the length of side C, which is 12. Okay, so here's my law of sines set up here, and what I would like to do is solve for either this value here, side A, this value here, angle B, or this value here, angle C. And I've got a problem now because I've got three different unknowns here, and yet I can't set up a proportion that will allow me to solve for any of those. If I can't set up this proportion, if I set up this one, then I've got an unknown A and an unknown B. If I set up this proportion, I've got an unknown B and an unknown C. And if I set up this proportion, I've got an unknown A and an unknown C. So my law of sines is not going to help me. I need some other method. Well, the other method that we're about to develop is going to be called the law of cosines. And what we're going to do is we're going to put since we're going to be using one of our trig ratios, and since in order to use one of our trig ratios, we need a right triangle, we're going to create, like we did with the law of sines, we're going to create these two right triangles here by drawing in this value that we're again going to call h for the height of this triangle. Now we've created two right triangles, and we're going to use three things. We're going to use the cosine ratio, and then we're going to use two versions of the Pythagorean theorem on these two right triangles in order to come up with the law of cosine. So let's see what that's going to look like. If I start over here, let me do my cosine piece right over here. The cosine, remember cosine is equal to adjacent over hypotenuse. So the cosine of 70 degrees equals adjacent, oh wait, I need another piece here. I need to have some expressions that I can use for these two sides of these two right triangles here. So since I know this whole piece here, this whole long side here is 17, let me call this piece right here, let me give it a value k. So k is going to be the length of this short side of this right triangle. So if this piece, if I call this k, and if the whole piece is 17, then this piece right here must be 17 minus k. Okay, now I've got everything labeled like I need it. Now I can say the cosine of 70 degrees is adjacent over hypotenuse, so that's going to be k over 12. And like I did before when I was deriving the law of sines, I want to set this up as a proportion and then cross multiply here. So 1 times k is k. K is equal to 12 times cosine of 70 degrees. And I'm just going to leave that in this form for right now, and I'm going to use this a little bit later. Okay, so there's my cosine piece. Now I've got two Pythagorean theorem relationships that I want to set up here. So let's see, let me do this one here. Pythagorean theorem. So I want to use the Pythagorean theorem on this small triangle right here. All right, Pythagorean theorem, here's a right triangle. Remember, the Pythagorean theorem says the the sum of the squares of the two legs of a right triangle is equal to the square of the hypotenuse. So that's going to be k squared plus h squared equals 12 squared. And now what I want to do is I want to solve this for h squared. That is, let me rewrite this. Let me move the k squared over here. So I've got h squared equals 12 squared minus k squared. All right, so, and now I'm going to leave this in this form. I'm going to use this and this in just a minute in this second version of the Pythagorean theorem that I'm going to set up. Okay, so let me set up my other Pythagorean theorem equation here. So now I want to set up a Pythagorean theorem equation with this other right triangle that I've got right here. So this side is 17 minus k, this side is h, and my hypotenuse is h. So this square plus this square equals hypotenuse squared. So that's going to give me 17 minus k squared plus h squared equals a squared. Now let me expand this 17 minus k quantity squared. That's going to be 17 minus k times 17 minus k. That's 17 minus k squared plus h squared equals a squared. So let's see here. 17 minus k quantity squared. So I'm going to use FOIL here. And that gives me 17 squared. I'm just going to keep that as 17 squared for now. Minus 17k minus 17k again plus k squared plus h squared equals a squared. Now I want to take, actually let's go ahead and I'm gonna rewrite my 17k's. 17 square, instead of putting those together and calling those negative 34k, I'm going to put them together as negative 2 times 17k. And we're going to see why in just a minute. Plus k squared plus h squared equals a squared. Okay, now I want to use the first of my substitutions here. I'm going to take this value here. Notice that I've got h squared equals 12 squared minus k squared. Well, I'm going to take this value and I want to substitute it in right here for h squared. In other words, instead of writing down h squared right here, I'm going to write 12 squared minus k squared. So 17 squared minus 2 times 17k plus k squared plus h squared. And now I'm going to substitute this value plus 12 squared minus k squared, since that's equal to h squared, equals a squared. And now notice my k squared terms are going to go away. K squared minus k squared, those two terms go away. So now I've got 17 squared minus 2 times 17k plus 12 squared equals a squared. Now I would like to do my second substitution, which is I would like to take this value here from my cosine, my cosine ratio here. And I'm going to substitute for value k, I'm going to substitute that in right here for this value of k. So if k equals 12 times cosine 70, I'm going to substitute that in here. That's going to give me 17 squared minus 2 times 17 times k, which is 12 times cosine of 70. There's 2 times 17 times k plus 12 squared equals a squared. All right. Now, this, believe it or not, is actually what we're looking for, and I'm gonna rearrange this just a little bit. I'm gonna put my a squared over on this side. A squared equals 17 squared plus 12 squared minus 2 times 17 times 12 times cosine of 70. Now, two things I want to note about this. One, notice that I now can solve for this value a, which is the distance between those two balloons. That was what I was trying to solve for in this example. Notice also, though, that I have what is, we're going to note in just a minute, I have the form of what's called the law of cosines. So first let's go ahead and solve for a. I've got all this, and even though it's kind of a long string of numbers, all I need to do is just put this into my calculator. That will give me a square, and I take the square root of it, and that's going to give me the value for a. And so if I put that in my calculator and I take the square root of it, then a is going to be 17.13 meters. All right, so that's the answer to this example 1, the distance between the two balloons. Notice, however, though, what I have here is that for this triangle right here, which is not a right triangle, for this triangle, I've got this relationship that says a squared equals 17 squared, 17 is the length of this side, plus 12 squared, 12 is the length of this side, minus 2 times the length of this side, times the length of this side, times the cosine of the angle between these two sides. In other words, I have a situation here where the law of sines wouldn't help me, and yet because it wouldn't help me because I didn't have enough information. And yet now I have a formula that I can use with this given information to solve for another side of the triangle. And that formula that I just came up with is called the law of sines. Excuse me, it's called the law of cosines. For any triangle ABC with sides A, B, and C, that is, side A is opposite angle A and side B is opposite angle B, like we've done before, the law of cosines says a squared equals b squared plus c squared minus 2bc times cosine A, or b squared equals a squared plus c squared minus 2 times A times C times cosine B, or c squared equals a squared plus b squared minus 2 times A times B times cosine of C. And you would choose which one of these equations to use based on what information you have for a particular triangle. So let's take a look at how we might use the law of cosines in another example. Example 2, it says solve the triangle, which means I need to find all of the missing angles, 2 missing angles and 1 missing side. Once again, I would like to solve this one using the law of sines if I can, because the law of sines is much easier to use. So let's start out with that and see if we can use the law of sines. So fill in my information. Actually, I guess I better label my sides here. This is C, this is A, this is B. Okay, so sine A I don't have. Sine A over 3 equals sine B over 2.5 equals sine 28 over C. And once again, I see that I don't have enough information to use the law of sines. I can't use any of these proportions because any proportion that I choose to set up, I'm going to have 2 unknowns. So I can't use the law of sines. I'm going to have to use the law of cosines. Well, okay. Law of cosines, I've got a form of the law of cosines that says c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. So I have all the information I need to use the law of cosines to solve for c. So let's use that one. C squared equals a squared plus b squared minus 2ab cosine angle C. And let's fill in the information and solve for angle C. Or excuse me, solve for side C. So c squared equals a is 3 squared, b is 2.5 squared, minus 2 times a times b times cosine of angle C, which is 28 degrees. And now I can plug all that straight into my calculator. Even though it's a long calculation, I can just type that directly into my calculator. That's going to give me c squared equals approximately 2.0057, and I take the square root of each side, and that gives me c equals approximately 1.416. So now I've got this side of this triangle. I found out what side C is. Now, notice I still have to find angles A and B. Now, there's actually, once I've found the length of side C, there's actually two ways that I could go about finding angles A and B. I could either use the law of sines. Now that I have some extra information here, I have this length of side C, I could use the law of sines and plug that in to find angles A and B, or I could use one of the other forms of my law of cosines. And I'm going to leave the rest of this to you. You can decide whether you want to use the law of sines or whether you want to use the law of cosines. You should get the same answer either way. So I'll leave the rest of these for you, and we will take a look at these tomorrow in class.